Okay, so for this problem, I'm going to use a question I got from ChemLibreText, and it says determine the empirical and molecular formula for chrysotile, I don't know, asbestos. It has the following percent composition, and I have it written down here. So 28.03% Mg, 21.60 silicon, 1.16% hydrogen, and 49.21% oxygen. And we're also given that the molar mass of chrysotile is 520.8 grams per mole. So if we have 100 grams of chrysotile, then 28.03 grams of it is magnesium. And silicon will be 21.60, hydrogen is 1.16, and oxygen is 49.21. And then the next step is we convert to moles. And remember, to convert to moles, you divide the mass by the molar mass. I have already chosen the 4 elements of interest. So now we convert the mass to moles. Okay, we find the values to be 1.15, 0.769, 1.149, and 3.0756. Notice that I have at least 4 significant figures in all of them, and maybe 5 in some. And the more significant figures you have at this stage, the better. Okay, do not try and round things up at this point because it's going to mess you up. And then to get the ratio, you divide the number of moles you have in each one by the lowest number of moles. The smallest number of moles in this case is 0.7690. So we're going to divide all these moles by 0.7690. The ratios, we have 1.5, 1, 1.5, and 4. Okay, we know that we never write compounds as Mg 1.5, Si 1, H 1.5, and O 4. We don't do that. We have to always have integers, okay? No decimals. So how can we solve this issue? If we multiply the whole thing by 2, then we have Mg 3, Si 2, H 3, O 8. This is our empirical formula. Because remember the definition of empirical formula. It should be the lowest whole number ratio. So the molar mass of the empirical formula is 260.14 gram per mole. And if we take that and we put that into our formula here, we're told that the molar mass of the compound itself is 520.8, which will equal 260.14 multiplied by an integer. So in this case, n equal 2, which means that our molecular formula will be everything here times 2. So we'll have Si 4 and H6 and O 16.